So my name is Feda from SMU. So I'm very happy today to share you some of the topics under this big theme called data in the modern world. Okay, let's just jump right into. All right, so today I'm going to share actually three parts. The first part, I call it the rise of data. The second part is the rise of AI. And the third part is the interplay between data and AI, in particular, the governance of data as an emergent asset in the age of AI. All right, so first of all, let's talk about the rise of data. So if you want to name one thing that grow the fastest in terms of value for the past 2 decades, it must be data. Because if you look at the past 20 years, data used to be something that just being treated as an input to a scientific model or something used by scientists to study the nature. But now data is everywhere, and data is driving all aspects of our daily life in the business. So we today need to take a whole new perspective to this new thing we call it data. And I listed the 4 bullet points here. So let's examine them one by one. The first of all is data now can do much more for us. Now, everybody talks about big data for the past 10 to 15 years. And why suddenly do people start to talk about big data? Because as I recall, almost 20 years ago when I started my PhD days, we are also looking at very big data. We were looking at, for example, biogene data, satellite data, road network data. They were also very big data. But at that time, data was not very interesting to most part of the business world, for example. And it is only because with the rise of these things called Web 2.0, where everybody can generate data about themselves, so that data becomes bigger now. So today, when we talk about big data, actually, the word big has a lot of different meanings. So later we're going to explore more. And as we said, data has come closer to our life. When everybody start to share data about the data themselves, so these data can reveal a lot of insights about our preference, about our lifestyle, for example, about what we like, what we prefer in terms of our daily consumptions. And all these insights were very interesting to all sorts of business. So that's why data comes closer. And now everybody's paying attention to this data. And also for the past 20 years, we have advanced greatly in terms of the technology to refine data, right? When we talk about data as a new oil, we're talking about refining data. So with the more advanced machine learning models, AI technology, nowadays we can dig out more insights and value from the data, and data can be better refined. So that's why putting them together, data can do much more for us than 20 years ago. Not only that, today we need to take a very different view of data in terms of business life cycle. We used to treat data as something as a byproduct in our business process, right? So if, for example, if you're in the F&B business, you do your F&B business, daily transactions with the customer, and during the process, you have accumulated a large amount of data about your customer. But then you put this data in your database or in Excel sheet, in your Word document, and you just put them there, right? And then after a while, you might start to think about what can I do with this data? So this is what we call a data engineering perspective to data. It means that we first have data accumulated, then we start to think about how we can make use of these data. But the problem is that this is a very passive way of treating data. And then by the time you start to think about what we can do with data, there's a gap there, because you might realize, oh, I actually don't have the right type of data for what I want to achieve. And sometimes the data could be missing, the data can be collected or cleaned in an inappropriate way, or so on. So instead, nowadays, we have to take a more proactive way of handling data, which we call engineering data. It means that we have to go backwards. We need to first think about eventually how these data can help my business intelligence, whether I want to use this data for cost reduction, operation optimization, customer acquisition, or so on. Then I need to go backwards to think about, if I want to use my data for that purpose, how should I collect my data? What data should be collected? How I'm going to clean the data, manage the data and map the data in my business ecosystem. So it's a very different view. And today we only have 1 hour, so we probably won't be able to expand on that. And if you're interested, welcome to join our SMU's program and follow up with our other talks. The third point is that increasingly, today's data ecosystem becomes more collaborative in nature. No single business nowadays can claim that they have all the data they need, they have the best model, they have all the computational resource. So entities, no matter it's public entities or private sector entities, in the future, these entities need to work together. They need to collaborate in terms of data, in terms of model, in terms of computational power to achieve a good customer intelligence. And as we are now seeing that with the rise of these ChatGPT and the latest AI models, increasingly, data becomes more important and we need to treat it as an emerging asset. So this brings us to the last point is data assetization or tokenization will be the foundation of the future digital economy. And when data becomes an asset, then we need to seriously treat all the topics related to this new emerging asset. For example, we need to govern the data, right? We need to trace the data. We need to talk about data provenance, data pricing, data modeling, auditing, and so on and so on. And this will be our topic in the second part. Okay, so now let's pause a little bit also to take a look at the digital economy in the so-called post-COVID era, because I think for Singapore, there actually has been quite a lot of change, I think, in the past couple of years during the COVID, because it actually forces many parts of our society to change in this data economy. For example, we are seeing a lot of changes in the user behavior, right? Before COVID, we are still doing lots of things offline. For example, we go offline to buy things, to queue for the bank service, and to do entertainment and so on. But because of COVID, we have to engage services in a very different way, right? We order food online, we do learning online, we do entertainment online, and so on. So the way users engage services are very different. And secondly, the way we acquire information also changed significantly over the years. If you think about nowadays, where do you actually acquire the latest information or news? Many of us no longer rely on newspapers, right, or magazines to acquire newest information. You probably get most of the news information from social network, from what people share in your friend network, right, what people share on the social platform. So social information is one important source. And then, of course, the other one is Google search. So we are increasingly relying on our information network, digital network to acquire our information. And thirdly, organizations also operate differently. The COVID years forces many organizations to operate in a decentralized way. So employers work from home, and events, conferences, seminars need to be organized with people attending online. And all these things eventually means that nowadays, the way data is generated, curated, and utilized is very different. All these platforms, these apps, these digital gadgets that we're using to engage service, to acquire information, to organize events, means that nowadays we are leaving tons of digital traces about ourselves, about the behaviors on these digital platforms. Again, so all these digital traces will be utilized to gain insight into ourselves. So increasingly, we are seeing this boom of data. And nowadays, we do have plenty of data to gain insight into all aspects of our lives. So there is a saying that nowadays, in the age of big data, you can know everything about a person, right? And in terms of global business transformation, in response to this user behavior change, we're seeing all the business are nowadays going mobile, going data-driven, going intelligent, going immersive. Okay, let's talk about data in a more serious manner. So data has been regarded as the world's new oil for the past decade or so, mostly because just like oil is the foundation of many important industrial products and many important resources that we can use in our economy. Data nowadays also form the foundation of many of our data intelligence. But one aspect people don't talk that much is that just as data is the new oil, oil needs to be refined in order to be used. Raw data cannot be used directly. We need to actually develop sophisticated machinery model in order to derive the right value out of the data. So what are the value of data, right? In particular, nowadays, we talk about big data. I want to actually still remind people of this very classic. This is not new. So IBM has proposed these 4 V's for big data quite some years back. But I think they still serve as very good foundation to start with. So for the completeness of today's talk, I just want to review these 4 V's for big data, right? So for big data, we used to say that the first V is the volume, right? Data is very big, essentially saying the volume is big, right? So even the data is, we're not doing nothing to the data, right? Data at rest. It means that, the volume is very large. On top of that, it's not only the data is large, but that data is being generated at a fantastic speed, right? We talk about data in motion. So today's platform including the social platforms like Twitter, like Instagram, like all these instant messaging devices, we are generating data at a phenomenal speed. All right, so not only that you have to handle large data, but you need to handle data generated in real time with a large quantity. And then the third V is about variety, right? Data comes in all kinds of forms, not only the numeric data, values, figures, right? We're now dealing more with text data, right? With the image data, with video data, with the social network data, and so on. So all these different forms of data need to be handled and analyzed with different model and different technique. And they have to inform one another to form an all-around intelligence. And the last V is this veracity. Just like today, we have tons of data generated, and particularly online. All these data, many of them are actually quite noisy, in the sense that sometimes you have to be really careful to distinguish so-called the misinformation, right? And today we are very familiar with all the rumors, the fake news online, and actually, Singapore government has been launching quite a number of initiatives and the research grant calls in order to fight against these online fake news and misinformation. So today, we say that you have to really be careful in order to distinguish the true data from the fake ones. So all these are the challenges and the characteristics of this thing called big data. Now, if we look at the big data from a more practical perspective, right? When we talk about the value of data to the business, we can actually zoom into these 3 aspects. The first one, we call it insight from scale. It means that indeed, big data can tell us something that small data cannot. And secondly, knowledge from enrichment. One of the greatest power of big data is when you actually integrate data from different sources, and all these different data are gonna reveal different aspects about your target entity. And finally, we're talking about agility from real-time responsiveness. That means that you will really have to handle data in the way that you cannot just wait for let's say, okay, another day or a week to process the data and do some backward analysis. Sometimes you really have to handle the data in real time in order to take advantage of the real-time responsiveness. Okay, so we're going to give some example under each aspect. So first of all, insight from scale. Now, there is an interesting thing about big data is that what could happen have all happened, which means that the volume of data is sometimes really the necessary condition and a key factor in the performance improvement of a model. Years back, there has been actually a very interesting paper published by Google. The title is called Revisiting Unreasonable Effectiveness of Data in Deep Learning Area. So the paper actually answers, to some extent, the following question. Which one is more important, data or algorithm, right? So as a computer scientist, for many years, we always think, and we still think probably, that algorithms or models is more important than data, right? Because this is what we've been working all our lives. But is it actually the case, right? In the big data age, you would actually realize that sometimes data could be more valuable, right? Data could be more important. So from their paper, they looked at a large number of important tasks in image processing. If I'm not wrong, they looked at over 20 very important applications in the image processing task. And without changing anything about the model, about the algorithm, by simply feeding the model and algorithm with larger amount of data, they found that the performance actually increases logarithmically based on the volume of training data. Meaning that if you just keep feeding the model with bigger and bigger data, then the performance will simply just keep improve. Okay, so that is really amazing, because that means, at least for some, intelligent task, data is actually the driving factor. Okay. The second aspect, knowledge from enrichment. Now, as I said, sometimes the greatest power from data comes from the fact that if you can integrate data from different aspects, you're going to review something that you cannot see from a single source of data. So just an example, if we take a comparison between a typical corporate internal database versus what we call the external big data platform, like our social platform, like all the social network data we're using. And you can clearly see the difference between a typical corporate internal data versus an external big data. So first of all, corporate data set, right? It is usually based on business transaction, right? So we call it transaction based. So for example, if this is an insurance company, right? Then the data about the customer is their insurance policy, for example, right? If this business is e-commerce platform, then the data about the customer is their order placed online about the goods and services from the platform. If this is F&B, then the data is about what people have consumed at the restaurant, for example. Okay, so transaction-based data is very accurate, is of good quality, but the problem is that you don't get to see much beyond that transaction itself, right? So for example, if I buy a new iPhone, for example, from online, right? If you just look at the transaction, you're only seeing this particular customer has bought an iPhone. But whether this customer is happy with her purchase, right? If the customer is not happy, is it because of the battery, or is it because of the feature? Is it because of the price, or because of other aspects? You don't get to see that from the transaction data alone. And in today's business world, if we are talking about, all around insight about customer and the good business service, we would definitely need to go beyond this transaction and to look at what we call the context, right? The information surrounding that transactions. So then you get to see whether this customer is buying this iPhone for herself or for her family or for her friends, for her kids, right? And if she's happy with the purchase and so on. Because very likely the customer is going to share information related to this purchase on all sorts of other platforms. For example, the customer may post a picture, a photo of her new phone. The customer, if she's not happy, she might complain about it on some social media and review platform and so on, right? So transaction versus context. This is a very important difference here. And then, of course, no matter how big the corporation is, usually the data about the customer is of limited coverage and of a very fragmented partial view, because you only get to examine the customer from your business. However, if you compare what people share on all their social platforms elsewhere, we call it societal scale, and it's usually multifaceted insight. And then the business data about their customer is usually static and of low frequency, right? It just depends on how often the customer interact with the business. For example, if you frequent the restaurant twice a month, right, then you only have data about the customer twice a month, right? Versus how often you share data on your external social big data platform, right? So that's dynamic and high frequency. And the last but not least, in the corporate database, you usually see individuals one by one, right? You don't get to see them in a connected way. You don't see how people connect to one another. Whereas on the others, external big data platforms, usually we get to see, how people are connected in the network embedded view. So we are seeing all these differences between corporate data and external data. Of course, we're not seeing that corporate data is not good, but it's saying that we have a lot to enrich the corporate data with by these external big data. So if we can integrate these external big data, then we can provide what we call this all-around customer understanding. All right, so imagine if we can somehow integrate users' data from all the different platforms, then we can use this insight to enrich this user identity inside this corporate data. In order to do that, we need to do something which we call user identity linkage. So in the corporation itself, one thing most of the corporations nowadays need to do in the modern world is that you need to do very good identity linkage, at least within your corporation. Simply said that you have to, you need to know what are all the things, all the products, all the services engaged by the same user in your corporate environment. And interestingly, this is actually easier said than done. And the larger the corporation, it is actually harder because large companies may acquire small companies and they may actually get the user customer data from the acquired small company. But then it is not always as easy as we expect to integrate the user data from the smaller company. And sometimes for multinational companies, you might have acquired your IT services from different suppliers, you might have different database and so on. So it is also not very easy to link all these information together. And then you also need to do this user identity linkage in the online world, meaning how do I know that this is the same underlying user, right? Corresponding to these different user accounts on all the different platforms in LinkedIn, in Twitter, Instagram, and so on, right? But if we are able to actually integrate this information and connect with the corporate's internal customer identity, then we will be able to provide this 360-degree customer understanding to the business, including, for example, their business profile, right? Including their social network connection information, including the propensity model across different products. Okay, the third aspect of big data is really about being able to respond to the real-time agility. So imagine now, for example, there are some accidents happening somewhere in Singapore, right? Nowadays, you definitely will not hear about this thing first from the traditional media, right? You're not going to hear it from the newspaper or TV news. Most likely, you're going to hear it from the social platforms by people who share these events, no matter it's in text or in visual forms, right? By people who are right on the spot witnessing this. So this is what, you know, the modern society is. It means that everybody is a source of news, right? Everybody is generating data about what's happening around them. So that's why in order to actually be the first one to detect these events or whatever that is happening that is attracting people's attention around the world, we have to have a platform or being able to really capture these signals. Sometimes we call this social listening, right? So usually if you look at social listening, there are a couple stages in this whole process. For example, first of all, you need to do what we call the event detection, right? You need to first of all detect this, sometimes we call it bursty event, right? Because these events, they suddenly attract a lot of public attention in a very short time window, all right? Then many of these events, they are actually very viral, right? They might subsequently attract a lot of attention and be impactful for a long time. But some of them could be just one, a sudden impulse, and then it wouldn't actually last very long. So we need to somehow predict whether this is a viral event or whether this is just some transient event. So this is the second step we call the virality prediction. And then with all these different information sources now we have, right? We can summarize the events with all these information. As some platform will give us text information, some platforms will provide us pictures and photos about this incident. Some platform will give us why these things happen. Okay, so if you can summarize with all these different sources, and then even better, if you can contextualize this, right, providing this event context by integrating related content from different sources, so that people can really understand what had happened and why it happened. And then finally, nowadays, we need good visualization in order to attract people, right? So visualization of this burst event is also very important. But if we're able to do that, now imagine that you will really be the first one to really get this real-time intelligence from all the big data platforms. Okay, so just now we sort of very high level examine the rise of data, right? In particular, why big data is now a hot topic and how and why it relates to all kinds of business. So next, we're gonna talk about the rise of AI. AI has been a hot topic since I would say 10 years ago. The success of AlphaGo, right, probably is a big drive for AI. AI has been researched for many decades, right? For 40, 50 years ago, people start to look at AI. But for a long time, people were actually quite frustrated in the research of AI because there wasn't much progress there. However, with the growth with the development in our hardware, like CPU, GPU, and it's particularly with the rise of data, right? With the amount of data that we have nowadays, and if we feed this data to models such as deep learning, then suddenly we realize, wow, we can do so much now. Okay, so then AlphaGo was the first drive, and I think, of course, more recently, ChatGPT, right, the so-called large language models, is another big drive for the AI. As we all know, that AI systems are now increasingly requested to make important decisions for us in many scenarios of our life. For example, right, we are not unfamiliar with autonomous driving, right? And many people probably have already tried the Teslas and these cars. So in the future, we can expect that more and more, in more and more settings, AI will be making these decisions in terms of our daily life. And then for healthcare, right, we now have expert systems that leverage potentially all the medical records and all the medical experiences of all the experts around the world. So these AI doctors are now playing increasingly important role. And in the future, actually, this is not something in the future. Already we're seeing that these AI doctors are more capable than human beings. They can identify tumors, cancers more accurately than any human doctors, right? So they're going to actually in the future assist us in making decisions about our healthcare. And then in less serious settings, for example, in commerce, in shopping website, right? We are constantly being recommended by AI algorithms, right? So all these machine learning models, they are recommending things. They're actually pushing things for you. We are surrounded by these recommendations by this AI model. So actually, in some sense, you can say that they are really controlling what we can hear, what we can see, what we can hear, and what we can know about. Now, with the rise of AI, we are actually seeing a growing concern about how we should make the best use of AI so that they are for human good or for social good. An increasingly powerful AI actually call for an increasingly more powerful AI governance. And this is actually what is important nowadays, because most of the research efforts are devoted to making AI more powerful. But once we have these powerful AIs, how to govern them, how to make sure that they are used or they can be used in the way that we can control is now becoming more and more critical and pressing. So if we going to examine some details in AI governance, these 4 items are now becoming really, really pressing. The first one, these large models are nowadays very centralized in the sense that usually a single company is taking control of the model. For example, ChatGPT is owned by OpenAI, right? So OpenAI is now charging, for example, $19.99 for the use of every a month, right, for accessing their ChatGPT. But what if they charge $29.99 next month and $49.99 next month? You probably don't have much choice, right? And if they choose to power off the model for some reason, nobody can control them. So if your business in the future is actually built upon this ChatGPT or these large language models, you probably will not be able to afford a sudden, cutoff of this model. So in other words, can we create a large language model that nobody can power off, right? So here we're talking really about the decentralization and democratization of these computing models. Secondly, transparency and verifiability of the transactions. Now, when we are doing all these transactions, when we are submitting all our data and queries to these models, we have a right to know how our data has been used, or whether our data has been used for the model training, or whether our data has been used in other ways that we don't know. So we need to know the actual usage of data. Sometimes we call it data provenance, that is tracing out the data in the whole usage by the model. So here, transparency is really the key. And sometimes we would also need to verify some transactions, okay? And then if everybody is contributing valuable data to train these large language models, then in the future, we can demand actually some of the profit allocation based on data contribution, right? So we will say that the profit allocation also needs to be fair in this case, right? And then finally, we need to hold model accountable in some case. If the model is is causing serious problems, we need to be able to go back and see which step of the model is missing important piece, and if it is because of the input training data, then we need to be able to trace back to where the data has been collected in the first place, how the data has been claimed, how the data has been managed, and so on. So this is called the provenance of data. And then, with the rise of ChatGPT and these large language models, we're seeing that the business competition is nowadays shifting from the models to proprietary data, right? It used to be the competition is, okay, whether your model is better than mine, or whether our business has developed, our data science team has developed a better customer recommendation model. But if in the future, 99% of the SMEs are realizing that, oh, actually, we won't be able to develop our own models because, it's not as good as what we can use from the ChatGPT, then eventually everybody's going to build a model, build a business on top of these large language models. So the competition will shift from the model to actually who owns the most valuable data. So your proprietary data from the business is going to be an important asset. Okay. All right. So now with data being so important, we can actually look at the bottlenecks and the problems in today's data ecosystem, right? So if we first of all examine, our data ecosystem from the participants' perspective, right? We're seeing that we have three type of participants in this model: individual user, business, and the government. And each arrow here indicate how data would flow between these entities, right? For example, let's first examine the arrow from individual to business, this blue color one. When individuals' data is flowing to the business, of course, this refers to all our scenarios where, for example, when we're using all these social networks, platforms, apps, right? We're actually submitting all our data to the business. So along this arrow, there are actually some quite well-known issues nowadays. For example, unfair value allocation, right? Although individual users are generating all the data, but unfortunately, you don't get a single cent from what you contribute, right? And this increasingly become a problem because people realize business is making tons of money from your data, but you're not actually taking any fair share from that. And this situation is being changed as in many parts of the world. For example, in California nowadays they have an act so that individual user, if your data has been used for training by a tech company in California, and you can claim a right to some of the profits from that company. Okay, and then weak data control. Nowadays we probably will not be sure whether we can actually delete our data or our account from any business, right? Because first of all, not many apps we use or many platforms we use give you the flexibility that you can delete anything you want, right? And even if you delete, are you sure your account or data is really being deleted from all the business database? So we are having very weak control of our data. And of course, this causes all the challenges to our privacy, right? Privacy protection. So there are lots of problems when individual data flowing from business. On the other hand, if we look at the individual data flowing from government, right? In the past couple of years, we're seeing Trace Together collected tons of data from everyone. So we also have concern whether our data will be protected well and how these data will be used. And then between the government agencies or between different business is a gray arrow and this purple arrow. We're seeing all sorts of problems. For example, data isolation, data wars due to regulations, due to policies, means that data is not very easy for data to flow between the different business entities and organizations. So there are lots of problems here. And also there are problems when we look at how the whole process of data from the raw data all the way to the application. So here, data need to be refined by models and be used in the application in order to generate value. But if you look at who actually owns each component, it's very disconnected, right? Individual users are the ones who owns their data, but users don't have models and they don't have access to the application. So who owns the models, right? The computer scientists, the data scientists, professors, they develop all the models. But, we don't have necessarily the data from the user. And of course, we don't have access to the applications. So companies would have the applications, settings, the use cases. But on one hand, they are also very constrained in terms of how they can acquire data from the user. And on the other hand, they don't usually have access to the state of the art in terms of model, right? You have to spend a lot of money to have a large data science team in order to develop that. So we have all these gaps and disconnectedness in the data ecosystem. And this brings us to the solution part is in today's collaborative intelligence setting, in order to make the whole thing work, we will need two important pillars in the governance part. The first pillar is trust. The second pillar is incentive. And you have to have both in order to make it work. Because if we only have trust, right? If we say, wow, we can actually protect your data well, we can guarantee your fairness and so on. But we won't be able to provide you any reward as incentive. Then nobody's will actually contribute data to this whole ecosystem. And of course, if you only provide incentive without guaranteeing trust, then people will be concerned. Okay, so we have to provide both trust and incentive in our current data ecosystem. So here I'm listing some technologies that is widely used or is playing an important role in today's collaborative intelligence. So on the trust pillar, we are using something we call the trusted computing based secure data binding. Okay, so this is based basically on a lot of cryptography techniques, for example, asymmetric encryption, hash function, all these gadgets. They can make sure that we can establish the proof of unique entity pairing, right? For example, we can prove the ownership of a piece of data, right? So you can, for the first time, you can prove that I really own something. If you think about for hundreds of years of human history, it is very hard to actually prove you actually own something, right? Now, physically, if you hold any asset, right, people can deprive of it by force. Now, if you produce any proof in terms of data record, then the data record can easily be duplicated and faked. So it is actually very hard to prove the ownership of something, right? So today's trusted computing-based technology can at least establish the proof of this unique entity pairing. And then we have decentralized, storage and ledger technology to actually make sure that the proof you have just established can be guaranteed to be immutable, right? So first of all, you need to make sure you can prove that something has happened. Then secondly, you need to make sure that this proof will never be tampered, will never be corrupted by someone else, all right? So putting these two things together, then you can establish the trust in the transaction, okay? Then open code-based transparency and executability will give you the trust for the future. That means whatever we have agreed upon, we will definitely make it happen. A big problem in the real world is that sometimes, even if you have agreed on a contract, you have signed a contract, you've agreed on something, but it may or may not be executed. And you sometimes cannot make sure you can enforce that. So we are now using technology to make sure that whatever that has been agreed upon will be executed accordingly. And then privacy is a very important topic. Everyone has been talking about privacy, and it is a very big topic now. So privacy aware computation means that how can you guarantee that you're bringing value out of people's data without violating their privacy, right? So here we're talking about different techniques. Don't have time to elaborate today. For example, so-called differential privacy, federated learning, zero knowledge proof. These are some of the popular techniques. And then fairness, right? So if a system is not fair, you don't have trust in it, right? If I contribute data and I feel that I'm not being rewarded proportionally, right? If somebody have contributed less valuable data, but that person is being rewarded more, then I will be feeling unfair, and then I don't have trust in the system. So fairness is also playing a very important role in the future data economy. But how to guarantee fairness? Fairness means that suppose you provide data. How can I give a price tag to your data, right? How valuable is your data? So this is a new research domain. We call it data pricing. How to price something as virtual as the data, which can be easily duplicated. It is very different from any physical world asset, all right? And then we also need to audit data, audit models. So this is very different from financial auditing. So in data auditing, we are really talking about how to actually make sure a piece of model or whether a model have used a piece of data for training or not, all right? Then on the other hand, on the incentive part, this is even more interesting and exciting because this is talking about all these new technologies, including tokenization of data, tokenization of model, and how to design so-called tokenomics, right? It means that, if you reward people with token, if you turn data asset into tokens, then how do you design a tokenomics so that the whole system can be run in a sustainable and healthy manner? Okay, so due to the interest of time, I'm not going to elaborate too much on here. So this brings us to another very, very hot topic nowadays is this Web3. Okay, so Web3 is the coming trend in terms of this collaborative intelligence, and it will provide both the trust and incentive that we just talked about to make this data ecosystem run. So what is Web3, right? To explain that, let's very quickly examine what Web 1 is and Web 2 is. So Web 1 is essentially a one-way data flow by putting everything offline to online, right? So that, it used to be you can only access this book or this material in offline by going to a library. Now people around the world can access this online through internet. So we call it one-way data flow is because all the individual users, millions of individual users, you don't get to put things online. You only get to read those information that put online by these official sources. Then around 2005, 2006, there came the Web 2.0. So that the one-way data flow now becomes a two-way, right? Individual users, you can also put data online. So we call it, you can write into the internet, right? From the advent of YouTube and from Twitter, these things, for the first time in human history, now you can put online your own videos and millions of people around the world can see that, right? And this Web 2.0 has given rise to the business for the past 15, 20 years of this boom. So here comes Web 3.0. This is because as we are uploading, contributing so much data, right, as we see nowadays, we start to realize that, we are not actually benefiting from all these things we contribute, right? And we don't actually own whatever we contribute. So here we're already talking about ownership, right? We're talking about Web 3.0 is essentially to solve the problem that you can bind your identity with all the data you generate, right? So this unique binding is the foundation of Web3. So in the Web3 world, you can guarantee the trust and incentive because you can design all your personal economy based on your identity. So I want to quickly show you an example of how we can turn our personal data, for example, as an emergent asset class now. So imagine we have a platform like this, where on one hand, we have data contributors, and on the other hand, we have data consumers, including all the business or the banks, government agencies, medical care, consultancy, and so on. So if we can have a platform to connect data contributors and data consumers, and we can allow developers to put their models online, right? And all these things will be rewarded proportionally by the contribution. So users will be rewarded by the data they contribute, model developers will be rewarded by the model they build, and the data consumers will eventually pay for the insight from that kind of data. So this whole ecosystem will allow individual users to actually benefit monetarily from their own data with privacy guaranteed. Okay, so in the future, you can imagine you're having your personal data bank, right? So your data, just like any other asset, you can deposit your asset in your bank and you can benefit financially from that, right? And in fact, in Singapore, we are actually seeing some effort along that line. For example, I'm sure many of you in the audience are using this U, right? U credit card. Now, if you think about U, what it does is it actually achieves this cross-platform customer intelligence. Because different from, for example, capital points or Changi point, it is no longer a point system in one domain, right? It actually cuts across different business. For example, this U actually connects your consumption in, for example, cold storage to 7-Eleven, to transportation, to IKEA, to also things. So it actually integrate, right? If you recall in our previous slides, integrate your data from different sources. And then by doing that, it can achieve an all-around user understanding. And then also, you can achieve the data will be leveraged as a whole, not as an isolated piece. Okay, so this, along with many other new apps we're seeing, that is trying to actually put users' data together as an emergent asset, and we can expect in the future that the U platform may actually give you more reward beyond the current point system, right? They can tokenize your data and then let you benefit more from this growing data economy. Okay, now the rest of the time, I want to just use 1 minute to quickly promote our Master of IT in Business. All the things that I talked about, if you want to know more, and if you want to know more systematically, you can look into our Master of IT in Business called MIT program in Singapore Management University. And I'm also teaching some of the core courses here, including data science for business, including the Web3 things that I just talked about. So we have 4 tracks. We have the analytics track, we have the artificial intelligence track, we have fintech track, we have digital transformation track, right? And our MITB program has consistently ranked in the top 3, top 5 globally in terms of IT for business. If you want to know more about that, please feel free to scan the QR code down there, right? And you can always approach our admin staff in SMU to know more about that.